Hey there, I want to run a really quick video to show you how to locate elements on a page that are nested inside other structures and that might be a little bit tricky to find otherwise. And we'll see how to do it with some really neat Serenity BDD features. I'm going to use this website here to demonstrate. And all I'm going to do is write a really simple test in plain Serenity BDD. Now, what I want to locate is if we scroll down the screen, at the bottom, we've got these sections, which is quite common on e-commerce site. We have different products, and inside the different products, we have sizes and colors and other elements and so forth. What I'm going to do is see how we can locate these different color swatches for different products, but in a more elegant and sustainable way than generally what I see in tests. Let's get started. So I have a basic Serenity test. The only thing I've done here is to extend UI interactions simply so that I can write the Serenity code directly in the test, which I would not normally do. Normally I would put this in a page object or an action class, but for the purposes of this demo, I'm going to be coding right here. Now, the classic way that you would locate elements on a page might be to use something like XPath. So if we have a quick look at this element, we can see, you may not be able to see, but it's got a class with swatch option color, and that's inside lots and lots of divs. Eventually there's a price box and a product item info, so lots of different divs here. There's a product item which seems to contain each one. Now what I want to do is locate the product item for Radiant T and get the colors for that. Now if you were to use an XPath expression, the XPath expression might look something like this. Let's go back to our code. We might do something like find all. So we find all, and then we pass in an XPath expression that could look something like this. Let's open up the screen a little bit. So that is the XPath expression. I won't walk you through how we find that. You can, I'm sure you know how to do that. But that is a fairly typical XPath expression where we find an element with a product item class that contains the text Radiant T. And then somewhere inside that, we're going to find a div, a collection of divs actually that match this class attribute. And now if we want to actually find what the color is, we have to go back to the class and figure out where the color is actually defined, because it's written down here. There are a few different ways we might do it. We might be able to find that text. If we look through this, we can find that there's there's an area label. Now that's a useful one. Often the area label is a good clue to find elements like this. There's also option label. So there are a few ways we could do this. But what we're going to do is we do the find all, and then we want to extract the area label. So we can do that by doing a map function. So we take the element and then we use element get area label. And so that will give us a list of strings. So I want to import the list, obviously, and then I can make an assertion, a search that colors contains blue, orange, purple. Perfect. So let's actually derive that from the name of the test, which is clever. So here we go, import static. We want the assertions from assert J, and that is our test. So if we were to run that, that will work. But the problem with that is the XPath is really ugly. The XPath is relatively long, a little bit cumbersome, and this is a simple example. In a lot of real-world examples, it can get much uglier than that. So a more sustainable way to get your elements is not to do one great big XPath expression that navigates all the way down the path, the page structure, but to find a section that you're interested in and then drill into it incrementally. And we can do that quite easily in Serenity. So rather than finding everything, the first thing we would do, we would find the radiant T section. So we could do that simply by removing the end of the section, going find the radiant T block, and then we can say, then find all. And now we can change selectors if we want. That's where it gets quite cool, because we can actually swatch. That would actually work, except it's not text. I don't know where that came from. It would be swatch option color. So that would give us a list of our web element facades, and then we can continue with our map operation and extract the value that we want. Now this is really cool, because from here, if it was some element with a text in it, we could then just go and say get all the texts and return a direct list of texts, or get the text content or so forth. So we drill into the element we want, and then we narrow down our selection, and we find the nested elements that we need. And this becomes quite powerful, because afterwards you can use this. You could, for instance, you can make this a configurable element, make this part variable, and then use a data-driven test. We could write a test that would check for each of these colors that we can see here. So all of those, radiant T, tank, hoodie, and so forth, we can check for the different colors. So this nested approach I find really, really useful. And sometimes people do say, yeah, well, isn't it slower? Well, actually, I've done some tests, and there's no speed difference between this approach and a single long XPath or even CSS expression. So it is very efficient. So give it a go and let me know what you think in the comments.